Okay, so here is the next shape. Move it out of the way. And tell me about this shape.
This actually I don't think is a right triangle. This is a different triangle. I believe this side was 7, this side was 3, and this side was 6.
Ah, okay. Now, let's say before we even got started, you said you're not sure if this is a right triangle or not. How could we check if it was a right triangle?
Well, we can use the Pythagorean theorem. So if this was a right triangle, this would be 36. 6 squared is 36 plus 3 squared, which is 9. And this should equal 7 squared, which is 49. And it does not.
No, it does not.
So this is not a right triangle. So we can start the same way. And mark these points. But then we have to figure out what this point is in relation to the other points. So we have to, since we know the sides, we can use the law of cosines to find what this angle is.
Okay.
So it says, well, cosine says we can say this side is 7 squared, so 49 equals 36, 6 squared, plus 9, which is 3 squared, minus 2 times 6 times 3 times cosine of this angle.
Okay. Well, let's be careful. Look at the law of cosines law you wrote down. So it starts with 7 squared equals 36 squared, or sorry, 36, 6 squared, plus 3 squared minus 2 times 6 times 3 times cosine of what angle are you going to use when you write the formula this way?
The angle between these two sides.
Okay, so what angle did you find?
This angle here.
Yeah, that's going to give you the cosine of that angle.
But we don't want that angle, so we want this angle. So we have, on this side we have to use a 3 squared.
Okay.
And instead of the 3 squared on this side, we put the 7 squared. So now,
Sorry about the cat meowing in the background.
9, so this together is 85, so negative 76 is negative 36 cosine.
Well, again, let's be careful. What should the law of cosines say here?
So we're subtracting
3 squared. Start from the beginning. 3 squared
3 squared
equals
6 squared
squared
plus 7 squared minus 2 times, this should also be replaced.
Yeah.
7.
So sometimes if you write down a formula wrong in the beginning, it's best to just erase the whole thing and start over. No, not now.
Yeah, but I'm just going to erase
Okay.
this. So this actually turns into negative 84
Okay.
cosine theta. So we get that 76 over 84 is cosine of theta.
Yeah. Which we could simplify a little bit. What's 76 divided by 2?
Oh, that is 38. So 38
Over.
maybe 42.
Okay.
And that can also simplify to be 19 over 21.
Yeah, 19 over 21 is cosine of theta. Now, we're not going to go through all the calculations, but why don't you draw a larger version of that triangle up here, and now that you know, we could use this to know what this angle is now. Now that you know that angle, what are you going to do next?
So we have this, we know this angle. Call it x degrees. So now we have to figure out what this height is and what this distance over is to find these coordinates.
Okay.
So what we can do is we can say the height equals, or sine of this x degrees equals the height over 6. So the height is 6 sine of x degrees. And this distance here, we don't really know. Let's see. Well, I guess we could figure that out because we know from the Pythagorean theorem, we know this length squared plus this length squared equals 36.
Right, how could we figure it out using trig though?
So, well, the cosine of x degrees is this length called b over 6. So this is going to be 6 cosine x degrees.
Very good.
And then we find this. So this is 0, 0, 7, 0. This would be 6 cosine x degrees, 6 sine x degrees.
And then
we find the equations of the lines
Yeah.
sort of in the same way.
right, and then we find the equations of the lines, and then we tell Mathematica.
Do that, yeah.
Print that. High five, great work. All right, let's go to the next one.